All right, let's crack open the coder's toolbox and figure out how a programming language like Python actually thinks. I mean, have you ever really thought about it? How does a game just know you've leveled up? Or how does an app know your password is the right one? It can all feel a little bit like magic. But it's really not magic at all. In fact, it's a simple set of tools for doing three things: calculating, comparing, and deciding. So let's go ahead and open that toolbox up.
First up, the most fundamental part of our toolkit, the tools for doing math.
Now, a lot of these probably look pretty familiar from math class, right? But Python gives us some other really powerful ones, like the modulus operator, that little percent sign, super useful for finding the remainder of a division. And then you have exponentiation for raising a number to a power, but where it gets really interesting is with division. So, this is a big one because it trips up a lot of people. A single slash is what we call true division. It acts just like your calculator and gives you the exact answer, decimals and all. But a double slash, that's floor division. Think of it as just chopping off everything after the decimal point. No rounding, it just gets rid of it.
Okay, so quick pop quiz. Based on what we just saw, what do you think is the output of 15 floor divided by 4? I'll give you a second to think.
And the answer is 3. If you got that, you're on the right track. 15 divided by 4 is 3.75, but floor division just lops off that 0.75, leaving us with the integer 3.
All right, time for the next tray on our toolbox. Now that our code can do math, how does it actually make a decision? Well, it all comes down to asking questions. Really, really simple true or false questions.
These are our comparison operators, and their entire job is just to compare two things and return a simple yes or no answer, or, in programming terms, true or false. This one simple output is the foundation for every single choice a program can make.
Now, this is absolutely crucial because it gets everybody when they're starting out. A single equal sign is a command. It's an assignment. It says make this variable equal to 10. But a double equal sign? That's a question. It asks, are these two things equal? One's a command, one's a question. That difference is a total game changer. Okay, so we have tools for math, and we have tools for asking questions, but what if one question isn't enough? That's where our third set of tools comes in, the logic toolkit. This is all about combining our questions. And you can build incredibly complex logic with just these three words: and, or, and not. And is really strict. It only says true if both conditions are true. Or is much more relaxed. It'll say true if at least one of the conditions is true. And not just flips the answer. True becomes false, and false becomes true.
So let's try it out. If A is 5 and B is 10, what's the value of this expression here? Is A less than B, and is B greater than 20? Think it through.
And the answer is false. So let's break that down. Python looks at the first part. Is A less than B? Well, 5 is less than 10, so that's true. Then it looks at the second part. Is B greater than 20? 10 is not greater than 20, so that's false. Since we used and, we have a true and a false, which means the whole thing comes out false.
So when we mix all these different operators together, how does Python know what to do first? It uses a strict set of rules called operator precedence. It's basically the order of operations for code. You probably remember something like PEMDAS from school. It's the same idea, and it guarantees that the code is evaluated the same way every single time.
Let's watch it in action with this complex expression. Now, Python doesn't just go from left to right. First, it finds the highest precedence operator, which is exponentiation, so 2 to the power of 2 becomes 4. Then it handles the multiplication and division, so 3 times 4 is 12, and 4 floor divided by 2 is 2. And only at the very end does it do the addition and subtraction, which gives us our final answer of 15.
Now, eventually, you're going to use these tools wrong, and your code is going to break. You're going to get errors. But an error isn't a failure. It's actually just the computer's way of telling you what it doesn't understand.
We can group errors into about 3 main types. A syntax error is like having a typo or bad grammar. The code won't even try to run. A runtime error happens while the code is running. The grammar is fine, but you've told it to do something impossible. And then there's the logical error, the sneakiest of them all. The code runs fine, but it gives you the wrong answer.
Here's a perfect example of a syntax error. Python's grammar rules say that an if statement needs a colon at the end. Since it's missing, the program sees the mistake and just stops before it even begins.
Now, this line of code is grammatically perfect,
But when the program actually tries to execute the command, it hits a wall. You can't divide a number by 0. It's impossible. So the program crashes right in the middle of running. That's a runtime error.
And then we have this one, the logical error. This code runs perfectly. No crash, no warning message, but it gives you the wrong answer. Why? Because of operator precedence. It does the division before the addition, so your logic was flawed, even though the code itself was fine. And this is exactly why programmers will tell you that logical errors are the hardest to fix. Syntax errors are pointed out for you. Runtime errors tell you exactly where the program crashed. But logical errors, they're like ghosts in the machine. They work silently, producing bad data, and you have to become a detective to hunt them down.
So when you really step back and look at it, this is how it all works. The most advanced AI, the biggest video games, at their core, they're all just built from these simple tools, performing millions of tiny calculations and asking millions of simple true or false questions every single second.
So we've opened the toolbox. We've seen how a computer really thinks. It isn't magic, it's just math, questions, and logic. You now have the fundamental building blocks for pretty much any program. So the only real question left is, what problem are you going to solve first?